you guys. Okay, so this your following test is coming up. It's going to be glass and about the parts and functions of the microscope and how to use it and how to put the slide in there. So also the steps of how to put the slide in there and a wet mount and also OG Simpson. Okay, so let's get started. Okay, so observe the bullets penetrating a window. Label the entry and the exit holes. So in this one, okay, so in this one, so in here, basically the A will have a wider crater. So if you look at in the center, right here, this is a wider crater than this one right here. Okay, you have to be very observant. Make sure you check which is the wider one, which is the smaller one. So the wider one would be the exit. That's where the bullet exited. Okay. So again, this is the bullet exited. Okay, so make sure you understand how bullets work on the window, where they exit or enter. So the entry would be, of course, a smaller one. Okay. Okay, so let's go to the next one. What two tasks are run on glass if it cannot be physically pieced together? So as we saw in the labs, it's density. Okay, so obviously in your labs, as you guys saw, that precision and accuracy has a lot to do with it plays with it very well. So you have to be very precise, very accurate about it. So basically that's density. Also refractive. Refractive, you have to be very observant. You have to have, and also this, the skills for it. So you guys just started. So I think you guys did a good job anyways. You did a really good job as long as you saw it and how it moved. Very, very good job. So again, that would be the refractive index. Okay. Number three, when tempered glass is broken, what do the broken pieces look like? So as we looked at the PowerPoint on Monday and Tuesday, it looks like diced, tiny pebbles, like fragments, and they are less dangerous as well. And identify the chemical added to make Pyrex glass. So also in the PowerPoint, we talked about Pyrex. This is basically glass that is used on the headlights of cars because they're always surrounded by heat, by the sun, and also by cold. The winters and weather. So also what we do in the house is we have glass baking pans. So we put that in heat, and that's why it's good to withstand that. And also in the classroom beakers, test tubes. And this Pyrex glass is mainly made of boron oxide. What is the bending of light waves as they change velocity when they go through a medium? It's called refraction. Draw a diagram showing radial and concentric fractures. So if you guys remember this, so in here basically you're gonna have these are the ones that look like a spider web. These are your radial, okay, and these that form second are your concentric. This is radial and this is your concentric. Okay. List three items made of tempered glass. Okay, so side and also the rear windows of your car or any car, and also FY glass tabletops as well. Okay, explain the process used to make laminated glass. What is this type of glass used for in our automobiles? So this is something that was also in the PowerPoint. It says two sheets of float glass bonded together with plastic film. The windshields of cars are also bulletproof glass, or shatterproof glass. What is the main ingredient in the ordinary glass? Also in the PowerPoint, we talked about how it was made of sand, which is silicon dioxide, the molecule. Okay, and let's go to the next page. So I know you've seen this picture before, okay? And this was in the PowerPoint. Um, and we talked about how uh, we have to look at how it runs. Like let's start with B, like A. So with A, you see where in A in here it terminates with B. It terminates. So if it terminates with B all the time, that means A happened after B. Okay, but B, because B never terminated. Look, if you look at B, B always continued on after A when it, okay, and then here it also continues with all of them, with C, D, and E. Whenever those radial fractures bumped into each other, B continued. It never stopped. But D stopped, and C also stopped, and E also stopped. It terminated. It terminated. So that means B happened before C, A, E, and D. Okay, so that means B is first. Okay, that was the first bullet. Okay, and then if we looked at A, okay, since we're looking at A, on A, um, we're gonna we're we're gonna look at A here. It happened. You see where it bumped into C? It C's radials, and it continued, and then it bumped into E's radials, and it continues. So that means A happened before C and E. It never bumped into D, so D, we're not really sure. Okay, but we know that it happened before C. Okay, so on this one, A will be next. Okay, and then we look at C, since we already did A and B. We look at C, and C happened. Let's see here. It terminated here, so we know that it happened after A and B. Okay, because right off the bat, it just stopped. Okay, so in here though, we need to figure out, since it never bumps into D, we need to figure out with E. So when we look at C here, it stops. It stops here. It terminates. That means C happened after E. Okay? So that means E is the third bullet. Okay? Now, if we look at C and D, they really never even bump into each other. We know that D happened way after B, and really that's it. So C and D, really, it's a big question mark. Okay, but at least we know for sure that these happened first. One, two, and three. Okay, B first. Oh, that was the first bullet. A, that was the second bullet. And E was the third bullet. Okay. Number 11, if a piece of glass is placed in a liquid and appears to disappear, what does this indicate about the refractive index of the glass? Well, the refractive index of the glass equals, so remember when it disappears, that means it has the same number. Okay, and the number varies from 1 to 2. Okay, but really that means that's your match. That suspect is guilty, okay, or seems to be guilty. You would probably have to keep in mind that unless you can piece it together, he would be a person of interest, to be more precise. Okay. Number 12. If the backline is observed moving towards the liquid, the refractive index of the glass is less. Okay, it's less than the known refractive index of the liquid. Okay, so again, because it's going towards the liquid, remember the Becky line will move towards always the higher refractive index, always. So that means that glass will be less than the liquid because that back line is going towards the liquid. Number 13. If the back line is observed moving towards the glass, the refractive index of the glass is greater than the known refractive index of the liquid. So again, the Becky line always goes towards the higher one. So since it's going towards the glass, that's why the glass is greater than the liquid. Okay, number 14. Yeah, the bright halo, remember another word to say halo is Becky line, is observed near the border of a particle immersed in a liquid of a different refractive index, and this is known as Becky line. Number 15. Okay, so this is basically a glass chip, is a chip that has a mass of 2.44 grams. So that's mass. Okay, so using the water displacement method, the initial volume is 10 milliliter. So that's 10 milliliters. And then the it increased to 12.6. So 12.6 milliliters. Okay, and keep in mind that this, remember, you always subtract the final minus the initial. So this is a final volume, this is the initial volume. So that will give you 2.6 milliliters. So that's why the 2.44 would be the mass and the volume would be the 2 milliliters is volume. So it's 2.66. You divide that and you get 0.938 grams per milliliter. Okay, number 16. Number 16. Okay, so if the laboratory can piece a broken glass from window or headlight together, then the evidence has individual characteristics. So if they can piece it together exactly alike, then it's individual. Otherwise, if they can't, then it will be considered class. Other ways that you can get clues is through the refractive index or density or the density. Okay. A piece of glass is immersed in a liquid. It proceeds to float in the liquid surface. This shows that the density of the glass is less than the density of the liquid. Okay, so always the one that has the least density will always be on top, okay, if it's immersed in a liquid. Okay, so now let's go into O.J. Simpson. On the night of his ex-wife's murder, where did Simpson go? Okay, supposedly he was in Chicago, or he did go to Chicago. Okay, so what evidence did LAPD officer Mark Furhan find in relation to the OJ case? Well, I don't know if you guys remember, but he went into his place and then he found a bloody glove. Okay, a bloody glove. And and number 20, what are the names of the two victims OJ was accused of killing? Nicole Simpson, which was his wife, and then Ronald Goldman, which unfortunately he was wrong place, wrong time. Number 21. Johnny Cochrane said, if it doesn't fit, you must acquit, in reference to, he meant the bloody glove. Okay, because remember, it didn't fit in his hand. Okay, but it was refrigerated for a while, so it did shrink. So I don't know if you guys read through that, but yeah, that's what happened. Number 22. Where was OJ the night his ex-wife was killed? Again, this question, I guess, yeah, I guess because it's worded it differently. So he was in Chicago. Okay, number 25. Okay, identify the weapon. Oops. Identify the weapon allegedly used by OJ. It was a pretty big knife, or it was a knife. Okay, so what are some of the sources of contamination by the police at the crime scene between Nicole Simpson and Ronald Goldman? Well, it was used towels to clean up blood. They, they used towels to clean up the blood. They threw the bloody towels on the bodies. The coroner was not notified till several hours later. Also, they did not change gloves regularly, and I don't know if you guys remember, but they also, oh, that question comes up in a little bit. Okay, okay. So yeah, there it is. What are some of the mistakes made by the LAPD investigator collecting DNA evidence in the Nicole Simpson and Ronald Goldman murders? Well, first of all, there you go. Did not refrigerate the blood samples. From what I remember, I think one of the detectives even put one of them in his back pocket. Okay, so yeah, big mistakes. Okay, so identify the different evidence found at the crime scene O.J. Simpson case. Bloody gloves, bowl of Ben and Jerry's, melted ice cream, bloody footprints. These are just some. Okay. Okay, in the O.J. Simpson case, the coroner failed to analyze the victim's stomach contents. So the coroner made a big mistake not doing that. This failure compromised the ability to estimate the victim's time of death of the victims. Okay, so that was a big mistake. And the time of death, we'll study that and we'll look at that unit towards the end of the school year. Okay, what evidence did OJ's lawyers use to discredit Mark for him? Okay, so he was caught on tape using, yeah, that word. Okay, so big mistake, of course, huge. Okay, so the number 31. If a laboratory can piece broken glass from a window or headlight together, then the evidence has individual evidence. I believe that was, did I just say that? I'm not sure. Okay. Anyways, the next one, now it's microscope. What is a method to calculate total magnification? So remember that you need to multiply the ocular magnification, which is 10, and then times the objective magnification, which could be 4 or 10. It just depends on what the objective shows, and that will be the one that you rotate in the nose piece. So that will be your objective magnification. Okay, to properly use a microscope, place the microscope slide on the stage and make sure you secure it with the clips. But keep in mind, remember that you're supposed to find your object first, and make sure you have your object in your eyesight. Okay, and then of course secure with the clips, and then you move that coarse adjustment knob whenever you need to. Okay, so a compound microscope is equipped with an objective lens 10 times and has a 10 times eyepiece. That's your, if you guys, that's your objective lens. So this is the objective lens. This is the ocular magnification. The total magnification, you just multiply those two, so it would be 100. Okay, the lens that is within the eyepiece of the light microscope, that's your ocular lens. Okay, be familiar, of course, with the steps to view an objective lens. And then you gotta know the parts of the microscope. And I believe these are only some. Okay, so like this is your ocular, that's your arm. Okay, that's the nose piece. These are your objective lens. Remember that you multiply those two. This is 10 always, and this is different numbers. It depends on which one you're looking at. That stage remember, it has clips too to hold the slide. That's your arm, and the big knob is the coarse adjustment knob. That's the one that usually moves the stage, or sometimes this top part. Okay, so the fine adjustment knob is the one that you fine tune it. And also one of the things that it's missing is a diaphragm. That's the one we use, especially if you used it wisely. You are able to see very clearly the Becky line. Okay, you're supposed to darken it a little bit so you can see the Becky line a little bit better. Okay, and then you're supposed to go from low to medium on the Becky line. But or you could see it in the low, but you could see it better in the medium. Okay. Also, the light source is back down here. Okay, and the base, of course. And that's pretty much it. And you know that this you work on your own. Okay, so and that's pretty much it, you guys. Good luck on your tests.